Got some really beautiful, vibrant, living compost here, full of microbiology, and we're going to grow cannabis plants regeneratively with this. So let's go and see what we can do with it. Living soil versus dead dirt. And this is compost that I made, and it's got a ton of life in it, including this guy. It's got hundreds, thousands of worms. It's got millions of bacteria. It's got nematodes, it's got protozoa. There's a lot of biology in here. And we're going to take that biology and we're going to make a compost tea out of it, and we're going to put it onto our plants, and that's going to be helping them grow regeneratively, getting carbon out of the atmosphere, putting it in the soil, and that's all with living soil biology. Plants take carbon out of the atmosphere. It's amazing. Carbon dioxide. We know there's too much carbon dioxide in the atmosphere, and they take it out of the atmosphere and they put it into the soil. And they put it into the soil as carbohydrates, as sugars, and they put that out through their roots, root exudates. And so right around the roots, what they call the rhizosphere, is where carbohydrates are being pumped into the soil by plants. It's amazing. And around about those roots, that's where the biology is going to gather, because that's where the food is. So there's a party going on around the rhizosphere, and all this biology in here is really digging it. They're like, oh yeah, there's all this food here, and we're going to have sex and reproduce and die and have our whole life cycle here. And that's producing the nutrients that the plant needs. So it's the plant and the soil working together, making both healthy. How about that? The plants feed soil, soil feed plants. And so the biology in the soil is what keeps the plant alive, and the plant is keeping the biology alive. So it's a symbiotic relationship. You can't really separate plants and soil. But having biology in your soil is going to make healthier plants. Healthier plants make healthier soil. Which comes first? Well, if you're making healthy soil and you add that around your plants, you're going to have healthier plants. And so we take compost, which I've got here, full of biology, then we make compost teas out of it. And those compost teas are adding biology to the soil around the plants. Healthy soil, healthy plants. We made 30 gallons of compost tea. Now we're going to look at one drop and see if there's any biology in it. Well, I know there's going to be a ton of biology in it. So just to show you, one drop. We'll put a cover slide on it, and we'll stick it under the microscope and see what we've got. This is a sample of the compost tea, and the compost tea, we've taken one drop, and the biology in it it's legendary actually. But this shows an insect larvae, and you can actually see its beating heart. You can see around about the mouth parts, the cilia there. And these can only exist if there is a lot of other smaller biology, that there's an active soil food web in our compost tea. And so seeing organisms like these, which are really macroinvertebrates in some ways, we're seeing big soil biology, which is relying on smaller soil biology. So we've got an active soil food web in here. And look, we've got some pretty interesting activity on this one. Super stoked about this. You can see all the bacteria in its gut. Anyway, this is under times 400. So I'm going to go back and see what else we can find. So I'm really checking on our to see that we've got biology in our soil and what kind of biology it is. And so in this, we always find bacteria. As I say, there's more bacteria in a teaspoon of soil than there are humans on the planet. But we are also going to be looking for nematodes and protozoa and microarthropods, in this case, insect larvae. So, for instance, I can tell that here we've got a fungal hyphae. And so I'll go up through the magnification, and they're maybe not that exciting, but it is for me. It's a fungal hyphae because 80% of plants have fungal associations with their roots. But down below it is a nematode, and the nematode's not moving around, which makes it a little bit not so interesting, but that is actually an unsegmented worm that's at the basis there. So there's our fungal hyphae, the thread, the body, the true body of a fungus, and that's a nematode. I'm trained as a cell biologist, and this is really important to tell the quality of your compost and your compost tea is to actually look at it. Otherwise you're guessing, you have no idea really what's in there. But when you put it under the microscope, you really do see what is in your compost tea. And what I'm looking for is all levels of the soil food web. And I want, of course, there's going to be bacteria in there, but I want to see protozoa, I want to see nematodes, and I want to see microarthropods. And in fact, in this sample, in our first viewing, we found all of those things right away. So I know I've got a healthy compost tea that is full of biology, and that's going to make healthy plants. Dun, dun, dun. Regenerative agriculture in action. You know, when you work in regenerative systems, you get unintended good consequences. For me, that's frogs in my compost. I didn't know they were going to turn up, but here they are. Sometimes, if I'm really lucky, I get salamanders. And that's a symptom of working in regenerative systems, unintended good consequences.